Good morning, everyone. As I see folks filing in, we are going to go ahead and get started with the webinar. Thank you for being here. This is just our next in our monthly series that we're doing on Cel-Fi products. This topic is around iBWave. We've had a lot of advanced questions and folks excited about this one with our technical group. Our technical group is kind of the rock stars of the company. So if you want to go ahead and get started, Mr. Hawk and Anna, why don't we move on to the next slide? And I'll go over kind of the rules. I'm Dean Richmond. I'm the Senior Director of Marketing here at Nextivity. The tool we're using today is Zoom. It's pretty easy. You see that Q&A panel down at the bottom of your screen. That is how you're going to ask questions today. If you want to ask questions, go ahead and type them in there. Myself or my partner in crime here, Emily, might be answering them in the chat itself. If it's something that we think the whole world needs to talk about, we'll go ahead and voice that one out for the whole group. Now, with that being said, there might be a question we actually might not know the answer to. So I may need to confer with Hawk afterwards, and we'll get those all answered in the next day. So ask away. There is no question off limits in that regard. So, and if you have a question afterwards, you can always email us afterwards as well. Now, the webinar itself is being recorded, and you will receive a link to view this recording. We'll actually post it on the website in the next 48 hours as well. But if you want a copy of the presentation, that is for partners only, and a PDF copy is available from your sales rep if you want a copy of that. So again, another way to ask questions is just simply questions@celfi.com, and we'll get back with you. Well, with that, I want to introduce a couple people on the next slide here. You are going to hear from Anna today, who is our Senior Director of Customer Support. She is quite the rock star when it comes to all things support. And then Hawk Un, he's a solution architect that works for Anna, and he is our iBWave specialist, and he will be bringing you some goodies on the technical side today. So with that, I'm going to say, Anna, are you ready to go?
Yes, I am. And thank you, Dean, and everyone who joined the webinar. Welcome. So the topic of the webinar, as you know, will be the in-building coverage planning using the iBWave tool. Prior to diving into the iBWave designs and technicality of it, I would love to introduce quickly our company, Cel-Fi by Nextivity. Our products have been approved for use across 200 carriers and operators in more than 100 countries. Last year alone, we have won 10 prestigious telecommunications industry awards, including the Tech Company of the Year, Innovation Leader for Cellular Technology, Advancement in Cellular Public Safety Communication, Product of the Year for an IoT Evolution, and many others. We have also just won our first award in January 2020 for the QUATRA 4000 product we have announced in Q4 2019. What is the true value proposition for our Cel-Fi innovation and technology? First of all, it is best in performance, provides 1,000 times stronger amplification, up to 100 dB gain versus the traditional systems. It also has the lowest total product cost, TPC, which supports the strong business case and ROI for our clients. On top of everything, it is very easy to set up, simple, and reduces the time to market. Our product is also network safe. It is carrier approved and endorsed. It has the self-organizing edge intelligence. There is no interference with other wireless products, and there are no risks for carrier or customers. It provides 100% peace of mind. What is actually Cel-Fi? Most of you joining this webinar are already familiar and know all the advantages. What's very important is that from the very conception, from the chipset to embedded software, firmware, hardware, radios, antennas, all the technical and mechanical design, this is done in our headquarters here in San Diego. It's an excellent team that also brings the latest innovation by creating state-of-the-art cloud tools such as our Wave Portal and Wave app that allow to monitor the performance of our product online anywhere you are. And this is the suite of our product line. We cover from multi-user solutions for vehicles and marine, Cel-Fi Go M, through up to 15,000 square feet coverage for small businesses and residential with Cel-Fi Pro and Duo Plus, small businesses, rural and industrial with Cel-Fi Go X. We have also created public safety version of Cel-Fi Go called Cel-Fi Go Red. And of course, our most famous enterprise product, Cel-Fi QUATRA, that covers middle price buildings and up to 500,000 square feet. Our product is so versatile, it can provide coverage off air or integrated with a small cell, which creates so-called supercell configuration. And it can be used for any operators in the United States, in particular the 4 top, AT&T, Verizon, T-Mobile, and Sprint, as well as many other Tier 2 and Tier 3 carriers. And now let's touch base on what's iBWave. As most of you have heard or are familiar by using iBWave, it is an award-winning integrated suite of products for planning, design, deploying, and optimizing of indoor wireless networks, such as cellular, public safety, Wi-Fi, IoT, and others. This is the official software used by major wireless operators worldwide, such as AT&T, Verizon, Vodafone UK, T-Mobile, and others. It is also supported by more than 300 equipment manufacturers, including us, Cel-Fi by Nextivity, Corning, CommScope, SureCall, Wilson, and others. iBWave also provides training and certification levels 1, 2, and 3, and in 2015 was acquired by Corning. Why is iBWave preferred by operators and other clients? iBWave is a complete platform from planning, site surveys, design, deployment, and optimization. It also provides project management software to manage all sites on the cloud and allows real-time modification to indoor design out in the field. iBWave also provides seamless integration with third-party tools such as drive testing and data collection tools to import your measured signal and perform the model tuning. The latest version of iBWave tool is R13.0.2 and is comprised of the three main modules. The first module, propagation, allows networks performance simulations. The second module, collection, enables import and display of RF measurements collected in the field by the data collection tools. And the third module, optimization, is used to detect and analyze surrounding outdoor signal performance, data throughput, signal quality, and possible interference. On this screen, you can see an example of the propagation simulation plot displaying the RSRP levels for an indoor coverage design. The color coding provides a visual picture in which area of your floor plan, in example of the building presented here, you have a desirable coverage. And as you can see, from neg 65 dBm up to neg 95 are the limits of the best expected or desirable signal. The second slide presents an example of the data collection imported into the iBWave tool. The previous plot was based on the tool simulations after using the predicted propagation model. This is the actual real signal measured at the site survey. After importing into the iBWave design tool, we can overlay it on top of our predictions, and most importantly, we can produce the model tuning. If we have started with the predicted propagation model, this will assist us to calibrate that model, and within the 5 plus minus percentage mean rate, tune the model so the final predictions can be as close as possible to the reality. And on the third snapshot, presenting an optimization example, we have displayed the signal to noise ratio plot, again, analyzing based on color coding. As you can see, the desirable levels are marked with green and blue, and the non-desirable in red, to assist us to identify where is the right signal to noise ratio or a lot of interference and pilot pollution so that we can optimize those areas. So it is a very comprehensive and useful planning tool, and you have an option from selecting the iBWave Design Lite or iBWave Design Enterprise Suite. Design Lite is the best choice if you need an entry level in building wireless network design for small to medium-sized projects. It works for passive DAS or off-air repeaters and would be the best for single building architectures, smaller enterprise designs, and coverage-based designs. For enterprise version, it is the best to use when we have large, high-capacity venues, complex building architectures, or would also like to do thorough data throughput and capacity analysis. All of these propagation, collection, and optimization modules are available at iBWave website for downloads for a 30 days trial, as well as your team members or any one of you is interested to attend the iBWave certification course, they provide the demo software as part of that process. Besides the tool, you can also download free iBWave viewer that allows user to view but not edit iBWave files. And they also provide the components database, so-called VEX files, at their www.ibwavecomponents.com. In Cel-Fi by Nextivity, we provide iBWave support in various ways to support our clients by sharing Cel-Fi components and VEX file that have parameters unique to our product and solution, to system design, reviews, verification, bill of materials for equipment lists and planning, cable routing, and also trainings and webinars. And this is an example of a system design plot for a 4-story hotel done by our iBWave team. As you can see, all of the equipment icons and connectivity. And the next slide presents the similar example of the cable routing for a 4-story hotel. And you can see the red lines and the green lines, and the ones that are producing the same type of cable routing design in iBWave can probably read it much easier. So why and when to use iBWave? iBWave, as you can see, allows for more accurate wireless performance for components and installation planning in comparison to the typical high-level estimation methods. Since it has capabilities for model tuning and optimization, it will assist greatly in improving the wireless performance of the system. And planning and simulation before physical installation is very important. First of all, it will meet more precisely customers' criteria and expectations. It will provide higher probability of that first-time installation success without having to go back to site and fix the errors, which is time-consuming and costly. It provides the fine-grained coverage estimation, especially in some very critical coverage areas. As you know, these type of designs are done in parking lots and other hard to cover situations. And it does provide optimized use of equipment and costs, as it is a very precise count. When do we use iBWave design versus other methods? If customers, especially operators, require visual display of key parameter indicators or KPIs, such as RSRP, RSRQ, signal to noise ratio, handoff, and others. When the clients would like to see the layout diagram and to produce more precise bill of material. If we're working on the pre-sales designs and only need a rough order of magnitude equipment count, Cel-Fi by Nextivity provides the QUATRA BOM estimator available on our website. And this is a snapshot where you can find our QUATRA BOM estimator. As you can see, it is very easy to input your floor information as long as you know the total area, square feet, what type of the floor area this is. If it's open, open plus cubicles, small offices, small rooms, you would select one of them or the percentage of combination of all, click and calculate, and then as an output here on the right side of the screen, it will provide the equipment count for every element of our Quatra system, which are network units, coverage units, donor antenna, QMA cable adapter kit, and Quatra range extenders. Please note that on our website, the calculation is only for Quatra 1000 system, which is our product for a single carrier. For Quatra 2000 product for 2 carriers, just please multiply the above values by 2. And for our latest Quatra 4000 product supporting 4 carriers simultaneously, our BOM estimator is in process and it will be posted soon. At Cel-Fi, we provide and make available to our clients Quatra VEX files and design templates. The Quatra VEX file contains full Quatra product lines and accessories for Quatra 1000, NU and CU, 2000, 4000 for all bands and models, even accessories like antennas and QREs, our Quatra range extender. Our configuration and design template provides a comprehensive range of Quatra configurations for different bands, small cell integration or off-air application, CUs, internal, external antennas, etc. Both of these templates are available for download at our website at the link specified here. And we also have made available templates for our latest product, Quatra 4000. And as you go to our website, by following the links in the previous slides, you will see that it is very simple and easy to find and download the templates and the VEX files. We have circled in red for Quatra 1 and 2000 VEX components and configuration design templates. And on the right side of the screen, the VEX components and configuration design and templates for Quatra 4000. As you can see, we also provide them for the international clients. It is worth mentioning that besides our Quatra product, we also provide the design templates and iBWave VEX file for our Cel-Fi GO-X product. GO-X that supports bands 2, 4, 5, 12, and 13, and improves cellular coverage in areas such as warehouses, petrochemical complex buildings, small office buildings, retail spaces, and as well for our public safety Go-Red version that supports band 12 and 14, and it's a FirstNet only variant. And in the middle, you can see the simple design produced by iBWave and the configuration for GO-X product. Our Nextivity VEX files and iBWave component database are connected. We also post our VEX file and configuration templates at iBWave centralized components database. And here is the website. If you, in the first window, select Nextivity Incorporated, then you will be able to display the whole library of our products, VEX files. What's the advantage of using our Quatra iBWave design template versus starting from scratch? On the templates, you already have the selection of the current configuration and design with the latest parameters. You have the ability to just copy and paste it in your iBWave design. You don't need to build it from scratch. This saves a lot of time and labor, especially for interconnection components like RF cables, jumpers, RJ45 connectors, etc. And it is easy to modify. Once you have the basic templates, you can replace the components easier than to search for them in the component database. So we try to make it easy for our clients. This slide presents samples of our Cel-Fi QUATRA product suite iBWave design templates. As we go further in our webinar, we will address each one of these templates individually. And this is the table that presents our Cel-Fi QUATRA variants comparison. I will now pass the microphone to my team member, Hawk Un, our iBWave specialist, level 3 certified.
Yeah, before we get into that table, this is Dean, and I am going to go ahead and ask that Hawk answer a few questions right now. On the BOM estimator, the question is, does the BOM estimator work with the Q4000?
Hi, this is Hawk. Currently, the BOM estimator does not work with Q4000, but we at the moment we are coming up to improve it, and shortly on our website, the BOM estimator will include, the Quatra 4000.
Okay. The next question is around the VEX files. Now, I know you do updates, and you did an update around Q4000, I believe. When was the latest file actually updated?
The latest files were actually updated on, I believe it's the 6th of February this year. So it's actually quite new for Quatra 4000.
All right. And how often are you doing those sort of updates?
Typically, I believe, the VEX file will be updated twice a year. So this will be every 6 months. I will try to update it.
Yeah, and also anytime we have a new accessory, right?
Oh, yeah, of course, definitely.
Right. So, great. Does iBWave provide an uplink speed prediction per carrier? Can you cover that in a little bit? Or
that will be on the, it depends a lot of factors, but I don't intend to cover that in this webinar because that will take too much time. But if there's a need, you can email this to, Cel-Fi, and then we can talk privately offline on this.
Okay. Great. I think those are all I'm going to ask for now, and we'll keep typing away in the background. Keep the questions coming, folks. Keep the questions coming.
All right, so thank you everyone for listening in, joining this webinar. So as Anna has mentioned previously, right, we do have the full Quatra, VEX file uploaded on our website and on the iBWave centralized component database. I'm the one that creates all these components, right? So as you can see on your screen right now, we do have currently 4 different types of Quatra model. the Quatra 1000, 2000, and 4000, and the 4000i, right? The main difference between all these Quatra model is the number of carriers they support. As the model suggests, right? The Q1000 only support one single carrier. It can be either AT&T, Verizon, or T-Mobile, but every hardware just support a single carrier, right? So if you need to deploy multiple carriers on a single building, you will need, multiple layers of the same hardware, as we're going to see later on, right? So the second one is the Quatra 2000. So Quatra 2000, as a model implied, it will support 2 carriers on a single Quatra hardware. So the Quatra 2000 will support AT&T. Sorry about that. Right. So the Quatra 2000 will support a configuration of AT&T and Verizon, or T-Mobile and Sprint. So it will support 2 carriers on a single hardware. And one thing that Quatra 2000 is distinguished from Quatra 1000 is that it only supports off-air configuration. Quatra 2000 does not support small cell like the Quatra 1000. So that's one of the main difference, right? And the latest product we just introduced is the Quatra 4000. So Quatra 4000 is to support 4 carriers at the same time: AT&T, Verizon, T-Mobile, and Sprint, or as we like to call it in the dash world, right? A full neutral host system. The Quatra 4000 supports off-air configuration and a small cell. Currently, the Quatra 4000 is split up into 2 different models, the 4000 and the 4000i. The 4000 is a consumer-grade booster, so it actually belongs to the FCC Part 20, whereas the 4000i is an enterprise-grade booster. It belongs to FCC Part 90, but both are very similar in terms of their performance. The only major difference is that the number of bands they support. As you can see from the table, right, 4000i support more bands compared to the 4000. The main difference in bands are the band 71, 41, and also the band 30, right? So those are the bands that, that requires a FCC Part 90 certification. So let's do a deep dive into the Quatra Cel-Fi configuration that is in the design configuration template that you can download on this website. So let's start with the basic, the Q1000. As we know, the Q1000 only supports a single carrier. So on your screen right now, I created this design template configuration. The top part will show an off-air configuration, and then the bottom is a same configuration, but using a small cell, right? So you can see that the network architecture remains almost very similar. You will always have a signal source, whether it's an off-air or small cell, followed by a network unit, what we call the NU, and then after that, the network unit is connected to the coverage unit by a LAN cable. This LAN cable has to be at least a Cat5e, right? You can use a Cat5e, Cat6, or Cat7, but minimum is a Cat5e because of the 1 gigabit data that is required between these 2 unit communication. And we all know that for LAN cable, we are restricted to the 100 meters distance restriction around 325 feet. If you need to extend this 325 feet further due to the size of your building or due to some other reason, we actually have a Quatra QRE called the Quatra Range Extender that can extend this LAN cable from 325 feet to double to 650 feet, which is the maximum, right? So if you see on the screen, the blue little component on the right side of the screen for every configuration, that is the QRE. So this QRE is supposed to exist between your NU and your CU. Right. So now that we have seen the Quadra 1000, let's take a look at the layout plan, right? So again, this layout plan is available in the design and configuration template. That is why I created it. You can just copy all this network architecture or configuration, as I call it, as you need in your project, and paste it onto your own iBWave design file. Once you copy and paste, all the network architecture is there. You don't have to recreate again. All you need to do is just, lay them on your, on your floor layout plan, like what you see on the screen here, right? So you can see that I just did a simple layout plan over here. What you see on there is all the antenna placement and also the NU placement. Very simple. So the next one is that for Quadra 1000, we also support the use of antenna, external antenna connected to our CU. This is what I call the horizontal passive infrastructure, right? In certain buildings or in certain regions, I may need to have external antenna connected to my CU. Yes, our hardware support it. In iBWave also created a separate batch file that allows the CU to be used external antenna compared to the CU internal antenna. The network architecture does not change, right? Except that I disable the CU internal antenna so that the two output port, the EXA and MIMO port, can be used to connect it to external passive infrastructure, as you can see on your diagram. On the diagram, I just use a simple two-way splitter. But, as you all know, you can use a coupler, a stapler, depending on how you want to tap out the power, for use by your external antenna. So next one, we move on to the Quadra 2000 architecture. So again, for the Quadra 2000, right, it supports two carriers in a single hardware. So you can see on the screen, on the left side, I have the AT&T and Verizon. On the right side, I have the T-Mobile and Sprint. So if I need to support all four carriers, all I need to do is to have two layers. The first layer is for Verizon, AT&T, and the second layer is for T-Mobile and Sprint, and combine them together, I have a neutral host system. Again, the architecture never changed. We have a signal source. In this case, it's an off-air, followed by a network unit, coverage unit, and a QRE if needed. Now, a common question is always, how many network unit can off-air configuration support, right? This will actually depending on your link budget. We always prefer the input signal coming into the Quadra NU to be at least minus 80 dBm RSSI. This value will provide you with the best output power in this case. So keep in mind that, right? If I have a strong donor signal at the rooftop, I can split it into multiple paths. In this example, I just split into 4 paths, but can I split it into 8? Can I split it into 16 paths? Yes, if my link budget allows me to do that. So your link budget calculation is actually quite important, to calculate the whole path, right? So this is Quadra 2000, as you can see. So again, in the design and configuration template, it is being assigned to a different floor for a component layout. So if you can take a look, compared to the previous Quadra 1000 layout diagram, this diagram is almost exactly similar, except that at every location, you have 2 CU compared to the previous one to be 1 CU, right? So every CU supports 2 carriers. When you have 2 CU, you support all 4 carriers. Right. So the next one, we come to our latest product, the Quatra 4000. So as I mentioned previously, right, Quatra 4000 is split up into 2 different configurations. The 4000, which is the FCC Part 20 model, and the 4000i, which is the FCC Part 90 model. As you can see, sorry about that. The network architecture never changed again. You have the signal source, in this case, is an off-air. For Quatra 4000, it's only for the off-air. I have not put in the small cell yet, but I'm going to add in shortly, in fact, in the next few weeks. Again, we have the network unit and the coverage unit. So one thing I forgot to mention is that the number of coverage units supported by the network unit increased for Quatra 4000. Previously, the Quatra 1000, 2000 support up to a maximum of 4 coverage units, whereas for Quatra 4000, it can support a maximum of 6 coverage units, as you can see in the picture, right? So if you can take a look, the NU, the network unit, followed by the coverage unit, and if there's a need, we also have the QRE. So for Quatra 4000. So instead of calling it the QRE, we call it the QRE 4K. So on your screen on the right side, you see that gray little component over there. Yes, that is the QRE 4K. Instead of the blue color, as you seen previously, now it's the gray color. Now, one thing to note is that for Quatra 4000, there is no internal antenna in the CU. Everything is external nowadays. So you can see that that's why in the configuration template, every CU is connected to an external antenna. The first 5 CU is directly connected to an external antenna, whereas on the 6th CU is connected to a passive infrastructure. Why I did this is to show you, you can have 2 choices, right? When you do a design for Q4000, I can connect directly to an antenna, you know, it's easier this way, or I can connect it to a passive infrastructure that can spread my power more evenly across a smaller area. So we're going to see. So if we can take a look at the network diagram, right, you can see that over here, you know, it's almost the same as Q1000 and Q2000. But if you pay attention at the, you know, lower right-hand side as my cursor shown over here, right, this is the passive infrastructure that I talk about. I can connect to my multiple antennas, you know, at the same time, you know, covering a smaller place, but providing a more even coverage. That's one of the, you know, ways if you need to cover a lot of small rooms, you know, and you can step out you know, some power out at each location to cover that area only, rather than to use a single CU to cover a white space, right? So this is a typical, you know, Quatra 4000 system layout. All this layout, all this network architecture, network configuration is available on our design template. So next we come to talk about the Quatra accessories, you know, that is available in iBWave, right? So I've created all these accessories like your QRE, your LPDA antenna, the small cell interface, everything is there, right? So of course, you know, the latest product we have is our Cel-Fi compass. As you've seen that, Cel-Fi compass that can be used for site survey, installation, and optimization, right? So for this, right, you know, I will end my part, but if you got any information, you can contact your master distributor or your customer sales team, or you can even email our customer support team at www.celfi.com, and then we will reply to your queries. Back to you, Dean.
All right, Hawk, thank you. So we've been feverishly typing in the background, trying to answer as many questions as possible that we thought were quick. But we thought we would save some for live, see how many we can get through. So first one up is, how do you apply in iBWave the power received at the donor antenna and the power output out of the Quatra CU?
All right, so let me go back here, right? So to put on a network diagram so everybody can see, right? You know, so let's take Quatra 1000 for example. So this is what we call a link budget calculation, right? Every component either have a gain or a loss. This includes your donor antenna, your cables, our NU and CU plus the passive component. Passive component can be your splitters, can be your hybrid couplers. So at every stage of the network, there's a link budget calculation starting from what is your donor signal being received, let's say at the rooftop, and then all the way down to the transmitting signal at the CU, right? So this is done in link budget calculation, and the iBWave will actually do it automatically for you. In the whole context of the Cel-Fi network architecture, I designed the system to have a max of 100 dB gain. This 100 dB gain is split up by the NU and the CU. The NU will always have a fixed 30 dB gain, whereas the CU has a variable 70 dB gain. And each band, if you were to double click on the CU, and each band, you can see that I can adjust the gain according to what I think the boosting system will give me, right? But typically by default is 70 dB of gain on the CU, which make it 100 dB of gain for the whole system.
Okay, another question, and I know you showed it, but if you can say it again, where do you find these iBW templates?
Oh, where do we find the all these templates? It's out on our Cel-Fi.com website on the Quatra 1000 product page and the Quatra 4000 product page under the download section, right? So these are the link over here, as you can see, right? So once you click on the link, it will bring you to our webpage. And for the Quatra 1000, 2000, you just need to scroll all the way down. And you can see that on the download section, we have the VEX file and also the configuration and design template. So for configuration and design template, I created multiple templates for different markets, right? For more specialized creation, you'll be better instead of, like previously, everything is lumped together and so big, it's hard to tell which is which. So I created specialized template for different market. So as you can see on the link or on your screen, I highlighted the US only market, but at the bottom, if you're from Europe or Asia, you can click on the bottom link below and download that specialized design template too.
Great. So with the Quatra 4000 CUs, we've talked about adding antennas, and they wanted to know what's kind of the max. You show 4, but how? I guess let me read the full question. What's the fair number of antennas that you would connect to a CU, given that the CU only has so much power? The drawing show has 4. Is that what our recommendation is? Is 4 our recommendation? Is that the max?
That's a very good question, right? I would not say so. In the design template, I put 4 just to show you as an example. Why I put 4 is because, remember, my building example, I have a limited amount of space over here, right? So you can see. I can't put in more antenna. If I put in more, the distance between each antenna become really short, and this become, unrealistic, right? So I'm restricted by the size of my example antenna. But to your question, how many external antenna do we recommend? That would depend on the type of indoor environment you want to cover, whether it's open air, cubicles, offices with drywall, or offices with concrete wall, right? So based on the link budget calculation that we did and the amount of power that our Quattro 4000 CU has, we on a typical basis, you can step up the power from around 8 antennas to 12 antennas, depending on the situation, in fact. There's no right or wrong answer, but this is the range of values.
All right. So one's a statement only because I know that several of our partners or several of the folks listening have listened to Joe talk about public safety and the upcoming ERC solution that we're going to be announcing at IWCE. This presentation does not cover planning for that product. More details to come is what I will say in general on that product. Stay tuned as we will have a webinar just before IWCE to give more detail around that solution. So please stay tuned for that. We're super excited. That is why we're not putting a lot of those questions out publicly right now.
Hey, Dean, I'd like to add one thing I forgot to mention. Since a lot of our partners, designers are actually on this webinar, all these partners previously has gotten hold of, this Q4000 VEX file that I sent out previously, right? There's a slight issue for the old Quattro 4000 VEX file is that it slows down the whole iBWave design processing time due to a fault by the design software. Whether, when you're adding more CU, when you add more NU, when you start to add more QRE 4K onto your network architecture, right? The whole processing slows down to a clock, right? I'm happy to say that I've updated the VEX file. So right now, there should not be any lag in using any of our Quattro 4000 VEX file. The new VEX file are available for download right now. Again, as Anna said, from 2 locations in the iBWave centralized database and also on our website. Remember to use the Quattro 4000 VEX file that has a date on it. The date is 02/03/2020. This is the latest Quattro 4000 component. Use that and you will not experience a lag on your design. That's it from me, Jin.
Okay, so I have got another one around asking about these VEX files. The VEX files, again, are available publicly on our website. So just go into the product page. You should be able to find them. And he's going back and showing that. Then I've got kind of a 2000 question that is in the down and dirty. What is the recommended distance between 2 CUs for 2 different Quattro 2000 systems on the floor? And I know you and Steve have covered this in other trainings. So what is the recommended distance between the 2 CUs for 2 different systems? And I know you kind of have that crisscross design.
So, the distance spacing between, each CU for Quattro 2000, right? again, there is no right or wrong answer depending on the environment from a design standpoint. But typically, we would recommend it to be placed, around 50 to 75 feet apart, in fact, to maximize the coverage area.
Oh, okay, great. And then I have another question around what's the minimum input power at the NU to achieve the max power with the CUs. I'm not sure if that's too technical to ask off the top of your head, or if you have to look that up.
No, as I mentioned previously, right? We would like the input signal into the NU port to be at least minus 80 dBm RSSI, at least minus 80 dBm.
Great. And then we got a question on whether Nextivity provides iBWave design, or is it through our partners that we do this? How do we support that?
So currently, if you need an iBWave design services, you have to go through one of our partners, either is it Get Wireless or Alliance, in fact.
Perfect. And we do have some partners, of course, that are doing enough of these themselves that they've actually gotten their own licenses as well.
Oh, yes.
So, all right. Let's see. What's my last question? So, as far as the separation between the CUs, not the NU and the CU, so this is just more of a clarifier. Don't we need a 75 feet of separation between the CUs if it's two different systems?
You mean the separation of just the CU?
Yes.
Of two separate systems? When you do separate systems,
Yes.
I'm assuming one is AT&T Verizon, the other is T-Mobile Sprint, right?
That is correct.
Oh, if that's the case, you don't need a 75 feet. That's too big, right? That's too huge. No.
But if it was for the same system, that's when the 75 foot.
Yes, if I have two AT&T Verizon, CU, right? This separation distance should be at least 75 feet to maximize the coverage.
Great. Well, we have reached our time limit and we're going to get kicked out of the webinar. We will answer the last few of these offline. We thank you. And again, our next webinar will be our very own Joe Smelser going over Quatra 4000, Compass, and Wave Pro, how those all work together. And we are anxiously awaiting that in a few weeks. Stay tuned. Thanks, everyone.